So dear student, just remember that in operator we are going to have two type of operator, that is binary operator and unary operator. Suppose if I want to get or know the relationship between the variables, I require relational operators. So what is type conversion? I want to convert the one type of variables into another type. Hello to all, a warm welcome to my new session on Introduction to C++. I am Revati, Faculty, Department of Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Before going to start my today's session, let me to recall the things what we learned in my previous session. In my previous session, we started with the introduction. That means how the C and C++ programs are differ each other and why the C programming is the most commonly used programming language. Along with that, we had discussion regarding the characteristics of C++ programming language. So what are the different kinds of C++ programming features we are going to have? That is object-oriented programming language. So what is OOPS here? So OOPS is nothing but it supports data abstraction, data binding, then message passing, inheritance, polymorphism. So these are the features of object-oriented programming language. Along with that, the C++ programming language is portable. Along with that, it is simple programming language and speed of the execution is high compared to C program. Along with that, it provides rich set of library function. And it is also used to develop system software. That is, it is mainly used to develop system softwares like driver software. That means the C++ programming language is mainly used to develop system software development. So these are the characteristics or features of programming language. Which programming language here? That is C++. And dear student, from the examination point of view, this is very important topic and you can expect 5-mark question. Along with that, we had discussion regarding the C++ character set. What is C++ character set here? Here C++ provides or supports some valid character set. That is, you can able to use the alphabet, that is capital letter A to capital letter Z and small letter A to small letter Z and the digit which starts from 0 to 9 and some operators like plus, star, slash or modulus. These are the certain character sets which is supported by the C++ programming language. Along with that, we had discussion regarding tokens. So what is token here? Here tokens are individual smallest units itself called token. So some of the example for tokens are identifier, constants, reserved. These are the example for C++ token. As I told, this is the smallest individual unit. That means consider the example that I want to construct a house. To construct house, what are the units I required here? I required rod, I required cement, I required sand, I required water, I required money. So these are the smallest unit. These are the small individual unit. Similarly, if I consider C++ programming language, identifiers, constants, reservoirs or punctuators or operators, these are the smallest unit. So these are the smallest individual units itself called C token. Then what is identifier? Here identifiers are nothing but the name given to the programming element. I repeat, here identifiers are nothing but the name given to the programming element. For example, consider that my name is Revati. So how you can able to identify me by the name Revati. Similarly, you can also able to identify me by the subject what I'm going to teach. So what subject I'm going to teach here? That is computer science. So by the subject what I'm going to teach, based on that you can able to identify. Similarly, if I consider any C++ programming language, what is identifier here? It is nothing but the name given to the programming element. Then I'm going to have the constants. So what is constant? Here constants are nothing but the integer constant, character constant, floating point constant and string constant. Along with that we discussed reserved words. So what is reserved word? These are the built-in word or the predefined word. So these are the certain topic we discussed in my previous session. But in today's session, at the beginning, I'm going to discuss C++ operators. Then I'm going to discuss unary operators. Along with that, the precedence of the operators or hierarchy of operators in C++. Along with that, we are going to study the type conversion. So dear student, these are the topics I'm going to deal with in my today's session. At the beginning, I'm going to have C++ operator. So what is operator here? Here operators are the symbols. For example, if I consider plus, minus, star or forward slash. So what is this indicates here? These are the operators or the symbols. For example, if I want to add two numbers, that is I'll write A equal to A plus B. So here A and B are the operands and plus is the operator. Suppose if I want to perform any kind of arithmetic operations, what I want to do here? I want to place the operator between the two operand. So an operator is a symbol. So what is the operator here? It is the symbol which holds some special meaning and that tells the compiler to perform some specific mathematical or logical manipulation or calculation. So what is operator here? Here operators are the symbols and it informs the compiler to perform some arithmetic operations as well as logical operations. And the C++ programming language supports 45 different operators and each operators is going to have some special meaning and they are responsible for performing specific task. So operators in C++ can be divided into following classes. That means what are the different kinds of C++ operators we are going to have here? That is arithmetic operators, relational operators, logical operators, unary operators, conditional operators, bitwise operator, assignment operator, and other operator. So dear student, just remember that the C++ operators are the very important topic from the examination point of view, and you can able to expect 5-mark question. So what is operator here? Here operators are nothing but the symbol. Example for symbol, it may be a plus or minus or asterisk or forward slash. These are the example for operator. And how I can able to place the operator here? For that I require two operand, that is A and B are the two operand, and where I'm going to place the operator, in between I'm going to place the operator. After adding A plus B, what I want to do? I want to store the result in some other variable. So this is the another operand. So I require two operand to place the operator, and where I am going to place the operator, in between the two operand. This is the example. So what example I have taken here? To find the sum. So what is the operator I am going to have? That is plus. If I consider equal, once again this is the example for operator. Then at the beginning I am going to have unary operator. So dear student, just remember that in operator we are going to have two type of operator, that is binary operator and unary operator. Suppose if I am going to have A plus B, so how many operator I am going to have? That is only one operator, and I am going to place that operator between two operand, and these kind of operators are called binary operator. And what is unary operator? If I use unary operator, then I'm going to have only one operand. So unary operators have only one operand, and they are evaluated before any other operation containing them gets evaluated. So what are the two different kinds of operator I'm going to have? Binary and unary. If I consider binary, I'm going to have two operand, and I'm going to place the operator between two operand. And if I consider unary operator, the name itself indicates that I'm going to have only one operand. So what is unary operator? That is, I'm going to have only one operand, that is called unary operator. And some of the example for unary operators are logical not, and, then, tilde mark, asterisk, plus, or increment operator, minus, or decrement operator. So these are the example for unary operator. Moving further, I'm going to have increment operator. So what is increment operator? That is, increment operators is used to increasing the value of an integer by 1. That means whenever I want to increase the value by 1, in that time I'm going to have the increment operator. So here think that A equal to 10. Now I want to increase the A value by 1. So how I'm going to write? That is A plus plus, that is equal to A equal to A plus 1. So what's the value of A? That is 10. 10 plus 1, it is 11. That means whenever I want to increase the value by 1, in that time I can able to use a plus plus. Or what is the increment operator? I'm going to have that as plus plus. So here plus plus indicates that increment the value by 1. So here this is the example. And in increment operator, once again I'm going to have pre-increment and post-increment. So what is pre-increment and what is post-increment? So here this example itself indicates that that means at the beginning itself increment the value, that is pre-increment, and perform some operation. If I consider post-increment, then perform certain operation, then increment the value. So it is pre-increment and this one is post-increment. Anyway, dear student, we are going to study what is pre-increment, what is post-increment, when we are going to use, what is the use, everything in our lab session. But in today's class, we are going to study the two different type of increment operator, that is pre-increment and post-increment. Then we are going to have decrement operator. So what is decrement? That means whenever you want to decrease the value by 1, that time we are going to have the operator, that is minus minus. So decrement operator is used to decreasing the value of an integer by 1, and it is represented by 2 minus symbol. Then how can I write? That is a minus minus. This is equal to a minus 1. So what is the value of a? It is 10. 10 minus 1, what's the value? It is 9. And in decrement operator, once again we are going to have pre-decrement and post-decrement. These are the two types of decrement operator, which are the two types, that is pre-decrement and post-decrement. Moving further, I'm going to have binary operator. So what is binary operator? Here the name itself indicates that I'm going to have two different operators. That means I'm going to have two operands. And in middle, I'm going to have the operator. Then we are going to have the arithmetic operator. So what are the arithmetic operators? I'm going to have that is plus. That means suppose if I want to perform addition, then I'm going to have the plus operator. If I want to subtract, then I'm going to have the minus operator. If I want to multiply the number, then I'm going to have star. If I want to divide the given number, then I'm going to have the forward slash. And if I want to find the remainder, then I'm going to have the mod, that is nothing but the percentage operator. So here arithmetic operators are used to perform some basic arithmetic operations. Then what are the different kinds of arithmetic operations I can able to perform? That is addition, subtraction, multiplication and division. So these are the example for arithmetic operators. So what are the operators? That is plus, minus, star, that is nothing but the asterisk, then forward slash, and I'm going to have the operator called mod. That means if I use mod, then I can able to get the remainder. And if I use forward slash, then what is my result? That is, I'm going to get the quotient. If I want to get the remainder, then what I want to use? That is percentage. Here percentage is nothing but the mod, that is MOD. These are the certain example for arithmetic operators. Then I'm going to have the relational operators. So what is relational operators? Why I required relational operators here? Suppose if I want to get or know the relationship between the variables, I require relational operators. So the relational operators are used to comparing two operands given in expression. So why I required relational operators? In order to know the relationship between the variables. So here variables are nothing but the expressions. So here I can able to get the two possibility. So what is the possibility here? That is nothing but the result. So that is true and false. So here true is nothing but the 1 and false is nothing but the 0. And what are the relational operators I'm going to have? That is less than or less than equal to, greater than or equal to and not equal to. So these are the certain example for relational operators. Now consider the example here. Think that A is 10 and B equal to 20. So what is the value I'm going to have? A is 10 and B is 20. Now 10 greater than 20. Is it true or false? Here 10 is greater than 20. It is false. So what is the value it is going to return? That is 0. So here 10 is greater than 20 is false, because here 20 is greater than 10. And if I consider 10 is less than 20, it is true and it is going to return the value true. That is nothing but it is going to return the value 1. And if I consider A equal to B, that is 10 equal to 20, it is false, because what is the A value? It is 10, and what is the B value? It is 20, and it is going to return false. That is nothing but the 0. So this is the way you can able to check the relationship between the variables. Then I'm going to have the logical operators. So what is logical operator? Here logical operators are used to testing more than one condition. So why I'm going to use logical operator here? That means if I want to test the condition more than one, that means testing more than one condition, I make the decision. In that case, I required logical operators. And the example for logical operators are and operator, or operator, and not operator. To illustrate the use of logical operator, consider the table. So here table is nothing but the truth table. So I'm going to have two variable. I'm going to have two variable A, B, and my output. Instead of writing 0 and 1, for 0 I'm going to use the word false, and for 1 I'm going to use the word true. So initially I'm going to have 0, 0, 0, 1, 1, 0 and 1, 1. So to represent 0 I'm going to write the value F. So how many zeros I'm going to have here? That is 2 zeros. So 2F, and this is for AND operator, that is AND. So it is for AND operator. So if I multiply, AND means what? Multiplying 0 into 0, it is 0. And what is the second combination I'm going to have? That is 0 and 1, that is F and T. So if I multiply once again, I'm going to get the 0. That means if I multiply any value by the value 0, I'm going to get the value 0. So here I am going to have 0 and 1, that is nothing but 0 into 1. I'm going to get the value 0. Now what I will do, I'm going to have another combination 1, 0. So here to represent 1, I'm going to use T, and to represent 0, I'm going to use F. 1 into 0, that is true into false, I'm going to get the value that is 0, that is false. And the last combination I'm going to have, that is true and true. So true into true, that is 1 into 1, I'm going to get the value 1, that is nothing but the true. Now if I consider the OR, that is nothing but the plus operator, then what are the combinations I'm going to have here? Once again, I'm going to have 4 combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. And to represent 0, what letter I'm going to use? That is F. And to represent 1, I'm going to use the letter T. So at the beginning, I'm going to have 0, 0, that is nothing but the F and F. So if I add 2 zeros, what is the answer I need to get? That is false. And if I'm going to have 1 false and 1 true, that means I'm going to have 0 and I'm going to have 1. If I add 0 plus 1, I'm going to get the result true, that is nothing but the 1. And what is the another combination I'm going to have here? That is 1 and 0. So 1 is nothing but true, and another one I'm going to have false. So to represent true and false, what is the value I'm going to have? True. That means if I add 1 plus 0, what is the value I'm going to get? That is true. And if I consider 1 and 1, so 1 and 1 means what? It is both the values true, then what is the output I'm going to get? That is true. That means for if I add 0 plus 0, I'm going to get 0. 0, 1, it is 1. 1, 0, it is 1. 1, 1, it is 1. That means in general, if I add 1 plus 1, I'm going to get the result 2. But if I consider logical operator, I'm going to get the value 1. And what are the different kinds of logical operators I'm going to have? That is and, or, and not. So what is not here? That is nothing but the complements. Suppose if I have 1, what is the complement of 1? It is 0. And if I'm going to have 0, and what is the complement of 0? That is 1. So this is the way you can able to represent. So this is the use of logical operator. So what are the different kinds of operator? I'm going to have and, or, and not. Moving further, I'm going to have the bitwise operator. Before that, what is bit? Here zeros and ones are called bit. So 0 and 1s are called bit, and to represent these zeros and 1s, I'm going to have the bitwise operator. So a bitwise operator works on bits and performs bit by bit operation. Now, what are the different kinds of bitwise operators I'm going to have? That is and, or, then I'm going to have the XOR, then I'm going to have the not, then I'm going to have the left shift, and I'm going to have the right shift operator. So here the bitwise operator is same as your logical operator. So here I'm going to have 2 AND operator, but here I'm going to have only 1 AND operator, and I'm going to have the truth table. So What are the possible values I'm going to have here? That is A, B and output. So here I'm going to use the bit. So that is 0, 0, 0, 1, 1, 0 and 1, 1. So it is bitwise AND. So what is AND? Here AND is nothing but the multiplication. So if I multiply 0 and 0, I'm going to get the output 0. 0 into 1, it is 0. 1 into 0, it is 0. 1 into 1, it is 1. And if I consider OR operator, then what is the output I'm going to get here? It is now plus or that is add. I'm going to have the truth table, and wherever I'm going to get the both the variables same value, that means when the variables are going to have same kind of values, in that place I'm going to write the 1, and for other place I'm going to write the value 0. So here I'm going to have the value 0 and 0. For that reason I'm going to write the value 1, and here it is 1 and 1. So I'm going to write the value 1. So this is the output for your XOR table. And you're going to have the binary left shift operator and binary right shift operator. For example, consider that this is your 8-bit number and you want to shift towards right. So how many bits you want to shift? That is 2 bits. So at the beginning I'm going to have this 0 is placed at the end, that is 0, 1, 0, 1, and this 0 is shifted here 1, 0, 1. And if I apply once again, then it is shifted towards back, that is 1, 0, 1, 0 and 1, 0 and 1, 0. So this is nothing but your right shift. And if I consider left shift, once again this is shifted here for the at the beginning, and for second time it is shifted here. This is the way the right shift and the left shift bit operators are going to work. Then I'm going to have the assignment operators. So what is assignment operator? Consider the example that you have 10 and you want to assign this 10 to some container. So what is container here? That is nothing but the A. So I'm going to assign the value 10 to A. And I cannot write 10 equal to A. This is the wrong expression. So how can I write A equal to 10? But I cannot write 10 equal to A. So the most common assignment operator is equal. So here I'm going to have certain assignment operator, that is equal, plus equal, minus equal, star equal, slash equal, etc. That means instead of writing A plus B equal to A, I can able to write plus equal B. And instead of writing A star B equal A, I can able to write A star equal to B. So these are the valid assignment operator. And to represent assignment operator, I'm going to have 2 lines. This is the assignment operator. Moving further, I'm going to have shorthand operator. So what is shorthand operators? Here C++ offers special shorthand offers simplify the code of certain type of assignment. Consider the example here. I'm going to have A equal to A plus B. This is the example for addition operation. Now I want to make this expression as small. How can I make it? That is A plus equal to B. So this is equal to A plus B. If I consider another example, A equal to A divided by B, then I can able to write A slash equal to B. So both are valid statement here. So these are the example for C++ shorthand. Then the general form of C++ shorthand is variable operator equal expression. That means beginning I'm going to write the variable, then operator, then assignment symbol and the expression. So this is the syntax for writing C++ shorthands. Then I'm going to have the conditional operators. So here the conditional operators are also called ternary operator. The simple example here that A equal to 10 and B equal to 20. Now I want to check A is greater than B. To represent these kind of conditions, I'm going to have the operator called ternary operator. So what I will do, that is I'm going to write the expression, then I'm going to write the question mark A colon B, and I'm going to write the termination symbol, and I'm going to store this value in one dummy variable called X. So what is the syntax I'm going to have? That is expression 1 question mark expression 2 equal expression 3, where expression 1, expression 2 and expression 3 are the expressions. And how the ternary operators are going to work: if A is greater than B, if this is true, then it's going to return the value A. And if this condition is false, and it's going to return the value B. So according to the example, what is the value? A is 10. 10 is greater than 20. It is false. So what it is going to return? It is going to return the value. It is going to return the value B. Because what's the A value? 10. 10 is greater than 20. It is false. So what is the value it is going to return? It is going to return the value B. So what is B here? B is nothing but the 20. And if I consider this example, here A is 10. 10 greater than 5. Then write the question mark and it's going to return the value 10. Else it's going to return the value 5. According to this example, 10 is greater than 5 and it is true, and it's going to return the value 10. So this is the example for ternary operator. And what are the operators I'm going to have here? That is nothing but the question mark and semicolon. Then I'm going to have some other special operators, that is size of operators. Now tell me why I required size of operator. Suppose if I want to return the data type size or the memory size, in that situation I'm going to use the operator called size of. For example, consider that I have defined int equal to, that is int A. So what is int here? Here int is nothing but the data type. And if I want to know the size of integer A, that is I'm going to write size of A. And it's going to return the value, that is what is the size of the integer. And comma. So here comma is nothing but the separator. Suppose during the declaration of any variables. If I want to separate those variables, in that time I'm going to use comma, and dot or arrow mark if I want to access member function or member operators used to reference individual member of class, union or structure. That means if I want to access any member of class or union or structure, that time I'm going to use the operator dot or arrow mark. Then cast. So casting operator, that means suppose if I want to convert the one data type into another data type, in that situation I require casting. Then I'm going to have the address operator. That means it returns the address of the variable. That means whenever I want to know the address of the variable, in that time I'm going to use the operator address. And star, it is nothing but the pointer. So these are the pointer operators. So what is pointer? It is going to point the address of the another variable. That is nothing but it holds the address of another variable. So these are the some of the special operators comes in C++ programming language. Then I'm going to have the topic, that is precedence of operators or hierarchy of operators in C++. So dear student, we all are familiar with the word expression. So we are going to have certain expression and I want to evaluate those expression. In that time, I want to follow the some rules. That means to evaluate the expression, I want to follow the certain rules. So I'm going to have the operator associativity. So if I consider the category like postfix, and I'm going to have the operators like parenthesis, brace, increment or decrement operator, and how I can able to evaluate. I'm going to start evaluating from left to right. And if I'm going to have the unary operator, then how I can able to evaluate, that is from right to left. And if I have multiplicatives like asterisk, forward slash or mod, then how I'm going to evaluate, that is from left to right. For addition or subtraction or shift, relational equality, bitwise and XOR or. So here what is the evaluation? That is left to right. That means I'm going to start evaluating from left to right. And if I get conditional and assignment operators, in that time how I can able to start my evaluation, that is from right side to left side. So these are the associativity of the operators that I want to follow during the evaluation of the expression. Then I'm going to have the order of the expression. That means which operator I want to consider at the beginning and which operator is going to have the higher precedence. So here the order in which different types of operators are evaluated is called operator precedence. That means if I get any expression, I cannot start evaluating directly because I want to consider the operator precedence. At the same time, I want to consider the associativity. So what I want to consider at the beginning, I want to consider the operator precedence. So if I get logical not operator, then it is going to have the higher precedence. Then if I get the parenthesis, then it is going to get the next precedence. And if I get the operators like arithmetic and modulus, then it is going to have the precedence, that is third precedence. For example, think that if the logical NOT is going to have the precedence 5 and it is going to consider at the beginning, and that is for 4, 3, 2, 1, minus 1, minus 2, minus 3, minus 4. So, these are the precedence. So, which operator is going to get the highest precedence? That is the logical NOT. And next highest it is parenthesis. And next highest it is arithmetic and modulus. And next highest it is arithmetic plus or minus. So this is the way you can able to start evaluating your expression. So before evaluating your expression, what you want to consider? You want to consider the precedence of the operator and associativity of the expression. So it's also known as hierarchy of operator. Now tell me how the expression is evaluated. So here the expressions are evaluated in the following sequence. At the beginning, arithmetic operator, then relational operator and logical operator. These are the expressions as well as operator precedence. Moving further, I'm going to have the type conversion. So what is type conversion? I want to convert the one type of variables into another type. For example, think that you're going to have 16.5. Now you want to make this 16.5 into round figure, that is 16. So this kind of conversion is called type conversion. That means I want to convert one type of data type into another type, that is called type conversion. So converting an expression of a given type into another type is known as typecasting or type conversion. That means you're going to convert one type of value into another type is called typecasting or type conversion. There are two types of conversion, that is implicit conversion and explicit conversion. So what is implicit conversion? So the automatically performed, that means the conversions are carried out automatically. Those kind of conversions is called implicit conversion. And who is responsible for performing implicit conversion? That is nothing but the compiler. So here the compiler is going to convert implicitly. The C++ compiler will implicitly convert or promote values if it can be done safely. Now consider the example here. So I'm going to have short A, and what is the value I'm going to have? That is 2000. And if I convert that into integer, then how can I convert? For that, I'm going to have the data type integer and I'm going to define the variable and I'm going to assign the value. Consider the example here. I'm going to have the value 20.65. Now, I want to convert this value to integer. How can I done? For example, I'm going to use the word that is float. So, here float is nothing but your data type and n equal to this value. Now, I want to convert this into integer. So, how can I? That is int number equal to n. So what is the value I'm going to get? I'm going to get the value that is 20. So here 20 is nothing but the whole number. That is nothing but the integer. So here the compiler is going to automatically convert the one data type into another kind of data type, that is called implicit conversion, that is implicit type conversion. Then I'm going to have explicit type conversion, that is here C++ is strong typed programming language, many conversion so easily. That means, so here I'm going to have short. Now I'm going to convert this one directly. That means I'm going to specify the type conversion. So here implicit type conversion means I'm directly going to specify the conversion type. So here I'm going to have short A, and what's the value I'm going to have? That is 2000, and I'm going to have int B. Now what I want to do, I'm going to convert this short A to integer. So directly I'm going to specify the type conversion. So which type of conversion? That is integer. Consider the example here, float. So here float is the data type and n is variable, and what is the value? That is 20.65. Now what I'm going to do, I'm going to convert this into integer value, that is integer data type number equal to int of n. So manually, that means I'm going to specify the conversion directly. So this kind of conversion is called explicit conversion. So dear student, in many programs we require to convert the data type from one data type to another. In that situation, we are going to use the type conversions. In my today's session, we started with what is operator and the different kinds of operators like arithmetic, logical, relational operators we discussed in depth. I hope, dear student, in my today's session, you got more information about the C++ programming. Let's meet in the next session with some more information about C++ programming. Until then, keep learning and keep watching. Thank you.